All attendees are in listen-only mode.
Okay.
Well, good morning, good afternoon, and good evening, depending upon where we find you in the TOC world today. For those of you who don't know me, I'm Marcia Hutchinson, the General Manager for TOC ICO, and it's my great pleasure to welcome you here today for this webinar with Oded Cohen, Managing Systems Part 2, Managing Processes Through a Combination of Time Buffers and Stock Buffers. For those of you who were not with us last week, let me tell you a little bit about Oded. Oded is one of the world's well-known names in TOC and he has over 35 years experience in developing, teaching, and implementing TOC methodology, solutions and implementation processes, working directly with Dr. Goldratt all over the world, and he's brought his expertise to education for a whole generation of TOC practitioners and implementers. Among the countries that Oded brings his expertise to are the United States, Canada, Japan, India, China, UK, Russia, Poland, the Ukraine, Colombia, Chile, Peru, and many others. He's an industrial engineer with a Master of Science in Operations Research and was one of the developers of OPT, the logistical software for production scheduling, the TOC thinking processes, and also the TOC management skills. He is a partner of Goldratt UK. Since 2001 has been a part of the Goldratt Group as an international director of Goldratt Schools. He's also a partner of TOC Strategic Solutions and the co-founder of the TOC Practitioners Alliance. Oded is the author of Ever Improve, A Guide to Managing Production the TOC Way. He co-authored the book Deming and Goldratt, and together with Jelena Fedruco, co-authored the book TOC Fundamentals. Oded is International Director of TOC Strategic Solutions Limited and a founder and co-president of the TOC Practitioners Alliance. And without further ado, let me introduce you to Oded Cohen and our webinar for today. Thank you for joining us.
Thank you, Marcia. Good day to everybody. We have quite a pretty schedule for this session, so let's see if we can deliver it on time. But I'm saying if we need some more time, some of the material may go into next week webinar on part 3. So what are we going to cover today? Last week we talked about the U-shape as the general structure and methodology of the TOC, and we will bridge it into the make-to-order MTO solution. We will talk about the direction of the solution, managing flow, the TOC and its uniqueness. We will talk about buffers, the time buffer and the stock buffers, the general structure of the TOC solutions for production, both the MTO and MTA, the buffers that we are using in the MTO solution, the MTO solution itself, at least the heart of it, not all of it, and yes, we'll build and we will summarize it with the relevant injection for the immediate improvement. So, generally speaking, the TOC solutions, the TOC solution for production or operation, and we will talk here, when we talk production, everything that we say about production is relevant for a operation as well. This goes back to the beginning of the TOC in the days of the OPT, and since 1975, the solutions have been developed for the make-to-order and make-to-stock environments. In the last 10 years, there has been a development of a specific solution of TOC for the MTS, make-to-stock environment, which is called in TOC make-to-availability, MTA. The solution is a combination of production with replenishment stocks. Today's session is going to be focused on the MTO environment. And I must say that the solution has been definitely developed over many years and evolved. And the the solution was not used or did not use explicitly the thinking processes in the development of that. Implicit definitely, because definitely the leadership was taken by Eli Goldratt, and he used implicit and eventually explicit the thinking processes in it. But the beauty is that even 20, 30 years later, you look on the solution through the eyes and the tools of the thinking processes, and you see how meticulous the whole thing was built to start with. The U-shape is going, we're using the U-shape in order to capture the relevant knowledge for the solution in a systematic way, and also in presenting the solution, so that you know, from the mountains of knowledge that we have, we can distill precisely what is needed in order to comprehend the solution and in order to be able to understand it and refer to it when needed. MTO, let's just agree on the definition, is a system based on customer orders which are specific while accepting response time that includes the production time. So we start with raw material. We're going through the production area. Then the goods are ready to be dispatched, put on the truck, goes to the customers. And from TOC point of view, the production management is all of the activities associated with managing the flow. Okay? So even though the production manager may deal with other issues like handling the personnel, like dealing with the machine breakdown, like quality problems, like many other issues, facilities, machines, everything is under the direct responsibility of the production manager or director. But when we're talking for managing production, for TOC point of view, we're talking only about the issues that are associated with the flow. Not that the other things are not important, but we are not dealing with them explicitly. Of course, we come across them. Of course, we suffer from them. We are getting them popping up in the buffer management and in the process of improvement, but we don't deal with that directly. So in this environment, what does the market want? The market wants reliability, the performance, DDP, and responsiveness, the quoted lead time. We will just remind ourselves what we covered last week, and that is always in the heart of the TOC, is that we are searching for improving the performance of the system under our responsibility. We are dealing with the production system. We are today in a situation on the curve, which is today with the current performance, and there is a strong belief that the system can perform fundamentally better on a higher level, okay? And if we'll continue to do what we're doing today, we will not get there, and there is a gap between where we are and where we want to be. This gap is providing us with the energy and the stamina and the desire to go and find a better solution, find other ways, go and learn, invest, make the effort, whatever it is. But as managers, we just believe that there is a better performance. So we are in this journey, we're using the U-shape. We start with the current performance, which is unsatisfactory. We do the analysis of the current reality in order to find what to change and which part of the system has to be taken out. We understand the problem, we move to the solution, develop the solution through stating what to change to, which is the new parts that are going to be introduced into the system, leading into the high performance. This will create the future reality, which over these 30, 35 years, we can say that there are many companies that this future reality has been their current reality for quite a lengthy period of time and pretty stable. All of this is connected in what we call the U-shape, and in the bridge between the problem to the solution, we deal with the pivot, and this is sort of the uniqueness of the solution, the contributions that the solution brings, the concept is bringing in connecting from the problem to the solution. When we're designing the solution, we're looking into the direction of the solution, the host of injections, including the injections that are supposed to prevent the occurrence of negative branch reservation, negative side effects, leading into the positive desired effects, all of which will create a higher performance of the area or the function that we are improving. And definitely there is a direct link between the solution and the injections to the undesirable effects that have been sort of the cornerstone for developing the whole analysis and understanding the problem. So we start with the current situation. In the MTO, the performance that is unsatisfactory is the on-time delivery and the quoted lead time, which is too long in the sense that it is not giving the company competitive edge when comparing to the performance of the other companies. Traditionally, there's a whole host of the UDIs that most of the people that have been a long time in TOC know them by heart. There's the fact that the resources are not available, priority constantly shift, raw materials and components or parts are not available when they are needed, too much expediting, too much overtime, too much rework, urgent delivery, the demand for that, too many inventory items that have too high inventory and obsolete inventory or dead items that is there. Not you know, too many of in this list, but they have definitely been consistently there, and UDIs that we have been meeting 10 and 20 years ago, they still happen to be today, which basically says that the environment inherently is not changing, and the TOC solution has a potential to continue and work. Diving down to the core problem is first of all presented as the core cloud. As I said, the objective of this cloud is to ever improve the performance of production that is under the control of the production management. In order to ever improve the performance of production, we must ensure on-time delivery of orders to the customers. And in order to ensure on-time delivery of orders to customer, we must take expensive corrective actions to expedite the flows towards the ordered completion. However, this is not always possible because on the other side, in order to improve the performance of the production, we must perform according to the official expectation of the system set by the budget, basically based on cost items. And we have to remember that as production managers, we have our own management, we are measured, we are getting bonuses upon our performance, and hence we better work in order to meet the expectation of the system. And in order to perform according to the official expectation set by the budget, we should stick to the plan that was set, the original plan, or officially updated. But this is still not enough, and this is in conflict with the fact that still we need, as a production management, to take expensive corrective actions in order to ensure on-time delivery. So this is sort of the core cloud. It has a other version, sometimes talking about dealing with local optima, which is in line with the ways that we are measured. So the D prime may be the local optima, whereas the global performance is talking about what is good for the company, and what is good to the company is that we give good service to the customers that happen to give us the money that the company needs in order to cover its own expenses and to make a profit and to flourish and to go forward. So this is quite a sincere cloud, and the reality is that this cloud exists and continues to exist. So let's try and understand more about this situation. So what is happening is that if we're looking on the planned delivery, taking raw material, push them through the production environment, bring to the dispatch area, on the truck to the customer. The reality is a little bit different, because we take the raw material, the time that it was supposed to take in production is now longer, and therefore we are late to get into the dispatch area, and even with a little bit of shortened and more expensive transport, we are late to the customers. So what is sort of the essence of the problem is the production lead time. The production lead time is the actual time that it takes to produce the customer order, and the issue is that in reality the production lead time takes longer than planned. So we have a wonderful system, and they are very expensive system, and they have all of these features which are geared in order to plan the production. But then the reality is that despite everything, the planning, the system, the management, the decisions, all of the infrastructures that exist there, the orders are late nevertheless, which means that the production lead time took longer than expected. So in general, when we said about production management, we're saying we are managing the flow. And the purpose, the objective of a production is to produce the goods needed for the customer orders. And when they are produced on time, within specs, in full, within quality, yes, by that, production is contributing to the goal of the organization. Practically, what managing production means is that the environment is organized in work orders, or sometimes it's used in production batches, and they are sort of sent on their way to the production flow, and with the expectations that they will arrive to the finishing line on time to the satisfaction of the customer. So we take materials from the material store or from the area in front of production. We release the work order. We send to the production. The workforce and the management are watching constantly the flow, and then when it is completed, it's put to the dispatch area. So the production management contains two elements: the planning, and the planning is planning of the work order release, what we are going to release, when we are going to release, and what are the quantity. And the second is, once it has been released and it is on the shop floors and it is expected to move, and then it's production management moving to maintaining and controlling the flow of the release work orders. And hence, when we're talking about production management, we're talking about planning and controlling the execution of the production plans. Okay, and from now on, when I'm saying the execution control, I will talk about what management is doing once the work order already has been released. And now it is on its way, it's a work in progress that is desired and planned to be finished goods that can be sold. So I still want to understand what is behind the core cloud and what is actually, can we pinpoint what is the core problem. So first of all, we said that the core problem has to do with the way production is planned, and thereafter the dynamic decisions that are done while the work orders are in process. Okay? So it has to do with the ways that we are planning and the ways that we are controlling the execution. Okay, and those of you that know the GSIM and then and the experiments that behind the simulator, yes, and how in a very nice way by playing the game we can transfer the message to the production management that the real essence of the problem is it is us. Yes, it is us, the ways that we are planning and the ways that we are controlling the execution. This is maybe a little bit unpleasant to understand, to accept for a person that has 10, 20, 30 years of experience. But the good news is that if it is done to us, then maybe we can do things like immediately, even before we are going to invest millions in purchasing new sophisticated systems for planning and controlling of the execution. I don't want to tell not to buy them, but I'm saying that it can start like immediately, and this is why we claim that it can we can have an impact in the short term. So when we are coming to planning, TOC claims that there are too many orders that are released too early, and they are released to the shop floor, and once there are too many work orders in the shop floor, we are creating a traffic jam that is very difficult to manage, and this is reflected in high work in progress. In execution, what is happening is that the work in progress allows production management to pick and choose what they really want to produce. And they can do batching, and they can prefer to do this part because it's maybe easier. Sometimes people may be getting higher bonuses for that when there was a piece payment, and when there are bonuses and premiums for high performance. And so there is the tendency to batch production, maybe save setups with good intentions to all kinds, but then when the panic mode comes and there is a need to break batches, and there are more setups occurs, and there is a jumping from one order to the other, management is forced to take actions that waste needed capacity, and the resources, machines that were highly loaded can turn into a temporary bottleneck, and that can be pretty painful. Just 1 second. Yeah. There is no, it's okay. There was a message on the network. That's fine. So I continue. I hope that. Sorry.
We can hear you.
You can hear me. Okay. Thank you.
It was just a little bit of a lag.
Okay. So just to summarize, is that in the area of the core problem, there are two issues. It's about releasing too many orders, and the second is that once there are too many orders in the shop floor, the ways that we are handling the traffic when already it's in a traffic jam. So we can say that the production planning and control system allows the flooding of the shop floor with work and allows too much freedom in the execution phase. Okay, and this is basically, first of all, you know that in TOC, when we're looking into the core problem, we don't want to finger point on people or functions, but when it comes to systems, yes, we are searching to find, what is not functioning well within the system and how we can improve the system, because in the end of the day, a part of the TOC solution is the system solution that influence the ways that we are managing. But definitely systems are there in order to help management to make the right decisions. And so and therefore we are very strongly converging towards the production planning and control system, not the function, the system that is using, whether it's the MRP, whether it is the bespoke system, whether it's manual system, it doesn't really matter. The concept on which the system is built. So once we sort of are talking about we have an understanding of the core problem, this is the time to go through the pivot towards the direction of the solution. Just a quick reminder from last week about the pivot. Okay, the pivot is in an sense what is the uniqueness of the approach. Okay? And when we're talking about managing the flow, we're talking about getting the management to focus on the flow. So the pivot is focus flow. So in the pivot, in managing the TOC way, we have the basic assumptions, we have the flows, 3 flows within the system, we have the constraint, we have the types of constraint, we have the concept of managing through the concept and the 5 steps of focusing. All of them, implicit or explicit, are definitely used in the development of the direction of the solution and the injections of the solution. So it's sort of the ingredients that we are using in developing a unique TOC solution. Reminded us about the flows, we said that there is the process flow. From the process flow, there is information about the status that is going up to management and to the workforce, and a decision is made, and there is a process, there is a flow of the decision from the workforce or from the management back to the process flow, the physical flow, so that either it can maintain the flow or speed it up or deblock whenever it's blocked. Whenever we are talking about any flow, there is, in the flow we have blocking factors. It can be to the physical flow, to the information, then the information does not get to the right people or to the management, and it can be that the decision flow is blocked and it's not arriving down to where it needed in order to ensure that the flow is maintained or accelerated. So once we are talking about flows and blockages, this brings us to the a constraint, and let's just remind ourselves the definition of the constraint, that the constraints are factors or elements that determine how much the system can accomplish. Not only what is blocking us, but what factor or element, if we will focus and if we will work according with it, we will have the ability to improve. So here we are. The constraint definitely today is blocking us and preventing us from taking off and getting into the high level of performance that we believe the system can achieve. However, if we will work on this factor will take us towards the direction up to the improved performance, closing the gap. Okay, so these are the constraints. So we are in the pivot. The pivot is managing constraint, and we ask ourselves, fine, but what is the constraint of manufacturing environment? The primary constraint is always the market. If we're talking about a company that wants to go up and up and up and up, and the company is a commercial company that is getting the throughput from the market, then the growth of the company is determined by the amount of customer orders, the throughput that they generate, and the fact that the additional throughput, every increment of increased throughput is larger than the increment in the increase of the operating expense, and of course this delta net profit helping the company to grow significantly. But there is a secondary constraint, and the secondary constraint is the constraint that is prevent the system, especially if we're talking about a function or a subsystem, from contributing to the primary constraint or achieving the primary, a better performance of the primary constraint. And therefore, when we're talking about searching for what is the secondary constraint, what we need to do is to go to the market and ask them and verify what is it they actually want. And especially when we're dealing with production, is what a factor of production determines the level of the customer satisfaction, because when they are satisfied, then we have a chance to get more customer orders and hence to improve the overall performance of the system. And in MTO we said that the market wants reliability coupled with quarterly time that suits their needs. Okay, so let's progress. The quarterly time is the time, let's define it, and shows that we're talking the same terminology. The time from getting the customer orders for the goods until the goods are ready to be dispatched from the company. Okay, this is definitely the majority of this time, and the last part is under the control of production, and production is the major contributor to that. Reliability means that when the company making promises, then the company delivers. It said, we will deliver on a such and such day, and then the reliability means that with very high probability, yes, the goods will be delivered on the time, or maybe a little bit earlier. Okay, so these two, what the market wants basically depends on managing the production flow, okay, in the production and the execution. And now we have a full alignment. Yes, we know what the market wants, and production can deliver that if we can plan the production and if we can control the execution so that we will deliver on time. So, flow. First of all, flow is characterized as dependent activities coupled with statistical fluctuation. So it's enough that we have two activities that one can start only after the completion of the other. Both are subject to variability of statistical fluctuations, and already we have a flow that needs management to ensure that it is under control and it is achieving its purpose. Now comes the key issue. The TOC way for managing flow is by using buffer for planning and buffer management for controlling and monitoring the execution of the plans. This is the heart. Let's define a TOC buffer. It's a mechanism that absorbs statistical fluctuation as well as to provide management with early signals that the process is in danger of going out of control and hence are under threat of not achieving the goal of the purpose of the system. So this is a TOC buffer, and it is planned as well as monitored and used in the execution. Okay. And of course, when you're coming into reality, the terms buffer is widely used, and people said, oh, we have buffer, we are doing that, we buffer here, we buffer there, and so on. And we say, guys, let's check. Does it meet the definition of the TOC? Yes? Because let's look on that. Because sometimes people, not only that they're putting buffers, they're also using the three colors approach, okay? And they add more and more colors into the system. And said, look, we have the colors in our system. And said, this is fine, but it is still not TOC, okay? So we have to be very, very accurate and precise in the use of the TOC buffers and what they're used for. Let's talk about buffer management. Again, from historical point of view, many people claim, oh, we have implemented TOC in production. The first question is that, are you using buffer management? And they said, using what? And I said, excuse me, yes, if you have implemented a TOC for production, you have put buffers, okay? If you have put buffers, do you manage the buffers? Do you manage with the buffers? And when the answer is not that clear cut, then we know that they are not yet there. So buffer management is a mechanism that informs management about the true status of the flow through the continuous update of the buffer situation as compared with the plan. Okay. And the buffers are used during the execution for setting up the priority and assigning resources to perform the job, this is what production management is doing, is assigning the jobs to resources, to people, to machines, and said you now go and do that and that. Buffer management is for the priorities. The second is prompting management to take recovery actions to ensure that there is enough buffers for the rest of the flow. The three is the proper sizing of the buffer through the dynamic buffer management or through managing the production lead time and measuring the progression and how it's reflected in reality versus the plan. The fourth is identifying reoccurring problems in the flow and eliminate them, and this is a part of the PUGI approach. So we can see that buffer management is a key of managing the execution. Just a general comment, buffer management is always oriented to the future. So we're saying here we are, what can be done in recovering, in ensuring that we will reach the finishing line on time. So, managing the flow the TOC way. Here's the flow, physical flow. On the top there is management and the workforce. From the flow we are getting information. It goes into the buffers. It can be to the production buffer, to the finished good buffers, to an stock buffer, to the project buffers. Okay, this information is getting to management. Okay, so from the flow to the buffers, from the buffers to the management. Okay, now management is assessing the situation and making the decisions. So, and instruct decisions to influence the flow. So this is now how explicitly we start to manage the flow using the buffers. Okay. There are two types of buffers. We can see it here. We have time buffers and we have stock buffers. Let's start with time buffers. Time buffer is a buffer that is measured in units of time, hours, days, etc. And the buffer prescribes an amount of time that is given to management to be used during the execution phase. The purpose of the buffer is to protect the delivery date that has been promised by the system. It is continuously monitored to ensure that it is not completely depleted before reaching the finish line. There are two major ways of using the time buffer. One is using the time buffer for the entire lapse time from the beginning of the process to the end. This is used in production MTO and in PTO purchase to order. There is another use when we add the time buffer and the add of the estimated time to perform all the activity of a process, which is based on estimations that are challenging but achievable. This is used in the project in CCPM. For production, the time buffer. We call it production or operation buffer. By the way, every time that we're talking about production, everything that we talk about production is true also for environment of operations. And, it can be any service environment, it can be a hospital, it can be anything else, and not necessarily a manufacturing environment, but it is just equivalent. Okay. And we're talking about specifically about the use of the production buffer in the SDBR for MTO. Okay, so this is the time that is given to production from the start of producing the goods that are needed for the customer orders. This is known as the point of material release, close the brackets, until it is ready to be sent to the customer. Okay, so here's the process flow. We release the material, and then we give the production or the operations a buffer that is bringing to the due date. Just to say here, when we're using the term due date, we're talking about the internal due date, because the date that is promised to the customer may be a little bit later to allow other activities, non-production activities. Okay, this buffer is usually dissected into 3 equal zones and colored accordingly with green, yellow, and red. 3/3 because 3 threads is simple. If other people want to make it more complicated, no fight about it. Okay, this is also the time to refer to the traditional full drum buffer rope for MTO. The one is that is described in definitely in the race. There are 3 different type of buffers, and one is called a CCR buffer, and if we're looking on this environment, is a simple assembly. The operation circle is a bottleneck or CCR operation. Then we buffer this operation by CCR buffer, which is the time that is allowed from the release of the material until it is expected to go on the machine and being processed. The assembly buffer is for the non-constrained items or parts. Okay, this is the time that is allowed from the release of the material until they are needed for the assembly, sort of a rendezvous between the free parts and the parts that are coming from the bottleneck. And the last bit is called the shipping buffer, and it is from the constraint up all the way up to the order in the market. In the case that there is no constraint, then in the full DBR we call it just a shipping buffer, and it is from the beginning to the end of the production of the items. So this is just to remind us about the history. Still relevant. Okay. The other type of time buffer is when it is used for project. Looking into a simple project plan, we have the critical chain. By the end of the critical chain, we put the project buffer, and when we have an integration of a feeder, we put the feeding buffer. The buffers are time buffers, okay, and basically you can find in the different software 2 types of presentation. One is sort of like a linear presentation by which the buffer is dissected into 3, and every time that there are variations on the critical chain that elongates the one of or several of the tasks, there is penetration into the buffer, and the buffer is consumed. The percentage of the consumption is one aspect, but the other aspect from a managerial point of view is the color. And hence, from early days, there was another presentation that was that has been used for quite a long, and this is sort of a tilted buffer or diagonal buffer, and basically is trying to change the structure of the red zone, because as we said, once there is a penetration to the red zone, management is expected to take corrective actions or recovery actions, and hence the horizontal buffer gives a little bit of relaxed mode of managing. Okay, the same goes into the feeding buffer, and just to remind us that this is how the diagonal or tilted buffer is presented, which is basically saying how much the buffer has been consumed versus how much of the critical or the longest chain has been completed. The other type of a buffer is a stock buffer that is used in the TOC replenishment system. There is, the definition is, stock buffer is a buffer that is measured in stock keeping units, SKUs, pieces, kilograms, meters, liters, etc. The buffer is the total amount of stock in the system that is planned for a specific SKU in a specific location. The TOC replenishment operates as a closed loop system. So when we're looking into the system, in the replenishment system, we have sort of three types of stocks in the buffers, or we can find them in three different locations: on hand, on the way, and to be ordered. The amount of the stock in the buffer is referred to either as buffer size, or also you will hear inventory target level. The buffer side is equal to the on hand plus on the way plus to be ordered. So let's look on how it is used. First of all, it is used in MTA, make to availability, distribute to availability, distribution, retail, and so on, and PTA, purchase to availability. Now we look and we see that what we have is on hand, and this is the amount of stock that is on hand, then is on the way and to be ordered. Okay, the sum of the three is fixed. Okay, what you see on the way, you see the black graph, and this is basically saying this is the current situation. The colors of the buffer are painted on the physical on-hand stock, and what is in stock is checked versus the total amount of stock in the system, which means the top of the green is what is expected to be in the entire system. When the graph reaches the top of the green, it means that all of the stock that is supposed to be in the replenishment system already is in the on hand. And when it hits the bottom of the red, it means that we are completely empty, and all of the stock of the buffer is not on hand, and hence there is no availability. So by that we've covered, you know, the different types of buffers that exist in TOC. Now let's move into the general structure of the solution of managing production operations. So here are some steps that basically describe how the solution is done. First, agree on the objective of the system, competitive reliability. Then, establish the two leading measurements. Not one measurement, there must be two, because if we have only one measurement, there is a risk that one measurement will be done on the expense of another important KPI or important feature of the system, and hence will lead to unsatisfactory performance of the system nevertheless. Third, establish the relevant buffers. Which buffer are playing in the solution. Release work to production based on the buffers. Prioritize the assignment of work to resources based on the buffer status. Monitor the buffer status frequently and take recovery actions when necessary. When is red, and definitely when it is in the black. In the red, it means that there is a risk. In the black, it's already past due and missed the due date. Ensure availability of raw material and components so that production can perform. use buffer management statistic for PUGI, process of ongoing improvement, manage CCR when necessary. When necessary, it's basically when the reality is such that there is a CCR, or through buffer management we identify that one or few resources becomes a capacity constraint, and they create blockages to the flow. And the last bit is resize batch quantity when necessary. So this is when the size of the buffer is causing difficulties to the flow. The general structure, we can look, and this structure is generic to both MTA and MTO. We want a reliability. The tactic is production and material management are on TOC logistics systems. There are 3 blocks. Mindset, that the production is to ensure competitive reliability. This includes injection 1. The second block is immediate improvement in reliability, and this contains a 4 injection, 2, 3, 4, and 5. And the last bit is a continuous improvement, the PUGI, which contains 3 injections. What buffers are we using in the MTO solution? In MTO, we want to achieve high due date performance and competitive quoted lead time. The core solution is the production buffer. Okay, and the production buffer is used. The production buffer is the time that the customer order spends in production, and it helps to determine the quoted lead time, because the quoted lead time is the production buffer plus some administration time that in order to do order processing, and some maybe additional time for administration for the dispatch, and that gives us the entire time for the quoted lead time. Okay, and once we have this quoted lead time and the production buffer, then the production buffer is there in order to ensure that production will be able to meet the due date that are going to be promised to the clients, the customers, through the quoted lead time. So immediately we're talking about how do we size the buffer. So there are 2 major considerations. One is that we want to give a good response to the market, and hence the production buffer should be short. At the same time, we have to be realistic, and we don't want to promise something that we cannot deliver, and hence there is a sort of a natural tendency to inflate the production buffer or the quoted lead time so that we would not be surprised, or sort of to give us a little bit more of a protection to be able to deliver what we promise. Nevertheless, what we know is that in practice, usually when we compare the production lead time with the touch time, the actual times that the work order is being worked on, then we find that the touch time is less than 10% of the production lead time, and in many cases fundamentally less. Even, you know, it may be measured in very few or maybe even less than 1%. And hence it's basically saying that the majority of the time the customer orders is sitting on the shop floor and either is waiting, queuing for machines, or waiting for a rendezvous with other parts that are coming to the sub-assembly and to the assembly. Okay, and this gives us quite a significant amount of time that is available there for better managing the flow, because what we're going to do is we're going to take some of this wasted time, the time that is there, and in order to shrink the production lead time. One more thing that is important to know is that the approach, the practical approach is that when we are entering into the red zone, is that it is expected that in a very extreme situation it will be able to produce the customer orders from the beginning to the end within the red zone. Okay, and therefore this is telling us that we have to consider the back-to-back time from beginning to the end, assuming that all of the resources are available in determining the red zone. Okay, and when we start the implementation, I'm not talking about a mature implementation and the ongoing implementation, that is the production lead time is all the time monitored and checked and updated. But to start with, we recommend that the size of the production buffer shall be not less than 3 times the size of the red zone and not less than half of the current production lead time. Okay, recommendation, and have been proven to be working nicely. Practical questions. What are we going to do with urgent orders? The answer, first of all, we highly recommend to limit the amount of urgent orders. Urgent orders is basically saying that they are promised less than the standard quoted lead time. Okay? There may be commercial issues and other consideration why to divert from the standard of the quoted lead time. Nevertheless, it is risky and it has to be very tightly controlled. But practically, if already it has been agreed to go for the urgent order, customer order, then it should be, the order should be given the standard production buffer, but when it is released to production, because the time has been cut, already there has been a penetration into the buffer, and it goes already with the right color and with the right penetration, as if it was supposed to be released at the right time, but it was not released for whatever reason. So, for example, if we have a customer order that has been promised for 50% of the production buffer, the order is recorded immediately in the yellow zone at 50%, as 50% of the buffer has already been consumed. Okay, and from now it's moving in the shop floor with the proper priority. So in MTO, we are using production buffer in planning to determine when to start the production, and in execution control to monitor the progress in assigning the resources and taking recovery actions when customer orders are in red or in black. Okay, so here it is. Here's the due date minus production buffer, give us into the order release, the material release, and highly recommended not to release too early because that will create the traffic jam, and the 3 zones of the time zones of the buffer. Now, also in the MTO we are using stock buffer, and this is in conjunction with injection 5 that is dealing with raw material and components. We will call them generically bought out items. This is everything that is procured from the outside world. And for the cases which the bought out items are expected to be available for production immediately, then the system is creating stock buffers and maintains them through the concept of purchasing to availability. It's the stock buffers with an inventory target that is the combination of on hand, on the way to be, plus to be ordered. It's a closed loop system, and this buffer is used for planning what to purchase, when to send the purchase order, setting out the priorities of chasing the vendors and the suppliers and so on, taking recovery actions, and PUGI. Okay, and just in order to get a flavor of it, yes, once we have the buffers, we have the buffer, the pictures of the buffer management. This is a normal behavior. This is sort of inability to sustain availability, because every time it drops below zero, and getting a supply and it is consumed and so on. This is overstock, and this is just panicking of the people that are managing. You know, first of all, they think that there is overstock, and then when they reduce the buffer through the dynamic buffer management, they find that actually there's not enough stock in order to sustain the demand of production for this material. Let's look on the MTO solution. As I said, there are three major blocks. The tactics is operations in production implements simplified drum buffer, rope, and buffer management to achieve high-duty performance. There's the mindset. Customer orders are the prime driver for managing operations and production. This is the mindset of the drum. Remember, we said that we have a market constraint. In order to exploit the market constraint, yes, we must build a plan. This plan is called the drum. The second block is immediate improvement in duty performance, and the third block is PUGI. In the first block, there is one injection that is dealing with the prime measurement of the production area. So the wording is achievement of the delivery commitment is established as the prime measurements for the production area. We're looking for availability, and before that we want to ensure that we have the right measurement. It's the due date performance as the prime measurement. At the same time, we have to understand that there is a prerequisite for that, and we have to ensure that the commitment to the clients, to the market, is done in a reasonable way, and this is why we expect to see there a drum, a sequence of customer orders with delivery dates that have been ideally done in a collaboration between the people who are taking the order, whether it's customer service or it's the salespeople, and production control. Okay, so what we see here is that we're looking on the time axis from now, looking into the future. There are 4 customer orders. Each one of them have a date. Of course, they have the definition of the goods and the quantities and the specification and so on, but we're looking on it from a time point of view. It's the customer orders, and the customer orders may be for one product, or it may be for a group of products and several lines, or it can be spare parts or whatever. So this sequence of the customer orders, this is creating the drum. Still within injection 1 is that how do we handle requests for a quotation. So we get a request, and a potential customer is saying, I want this and this, give me delivery dates, and the delivery dates should be the later between the requested time by the customer and the current lead time, the current date plus the quoted lead time. Exceptions, rush orders we discuss, and also there are situations that which is the RCCR. Injection 7, we will not deal with that today, but it is in the advancement part in the PUGI, deals with what do we do when we have a CCR and how the CCR is influencing the quoted lead time, because it is obvious that it is the quoted lead time with the CCR. We cannot guarantee the on-time delivery according to the standard quoted lead time, and we have to quote specifically. We are moving to the second block, immediate improvements in due date performance. It contains for injection. 2 is dealing with using the production buffer for planning. Injection 3 and 4 is using the buffer status for assigning resources, priorities, and for recovery actions. And injection 5, which deals with the raw material and components, contains within it planning and execution at the same time. Injection 2, production buffers. Production buffer is said to be challenging but achievable with raw material released accordingly. We have discussed a lot about it, but this is just a summary. The injection contains the following elements: the definition of the production buffer, the understanding of it, the status of it, the sizing of it, okay, which is should be achievable, but at the same time has to be challenging and not to allow too much spare time within that. That's why we many times recommend take the current quoted lead time and cut it by half to start with. And the additional things that we want to discuss here is the material release, the signal to start working on the orders. So we have the production buffer, okay, and the material release, the plan is based by calculating the time from the due date, the order due date minus going backwards in time, okay, when to start. And this is what is called in TOC the rope concept, that is saying when to release, but try to prevent too early release. Okay, we take the due date minus production buffer. Okay, this is the rope, material release, and recommend not earlier. Okay, very important message. Material release is a signal for production to start working on all working orders that correspond to a specific customer order. Okay, because we can have all kinds of environment, all kinds of production flows. Okay, there are two different entities. There is customer order and there is work order. The work order is a production entity. Customer order is an entity of working with the market, okay, and the official commitment, okay, and while we are dealing with injection 1 and 2, we have to translate customer orders into production work orders. Injection 3. Work orders are sequenced according to their buffer status through using buffer management. So what we have is the time flow, the progression of the time from starting of the material release, okay? Actually, from the planned release, the time starts to click, okay? The first third is green, the second third is yellow, last third is red. If we pass the due date, we are moving above 100%, and this is past due. Okay, so the moment that we planned to start the release, wherever it's released or not, the time is clocking, and the buffer status prompts management to interfere when necessary. The more buffer is consumed, the more attention management has to give. Okay, so if we're going to the resource allocation, and we are coming to a machine, and in front of that there are 3 work orders in 3 different colors, or 3 different, within the same colors, 3 different penetration. First of all, the color wins. Regarding a priority within the same color, sometime we may say that give some flexibility to the local production management, and in some other cases it says you just stick to the penetration, and what has higher penetration to the buffer must get higher priority in assigning the resources. Here's a typical report that is showing the different open work orders, their buffer size, the penetration, the percentage of the penetration. The black are over 100%, and then they are sorted out by the level of penetration. Injection 4. Buffer management for recovery action is in place. What is basically is happening is that we know that the reality is that Murphy starts to hit us, okay? And the machine breakdown, material is not available, there's absenteeism, changes, quality problem, you name it. You know, Murphy says that if something can go wrong, it will. It definitely happens in the shop floor, okay? But now when we are entering into the red zone, then management is expected to take more active role in taking actions to ensure that the order will be finished and dispatched on time. Okay, and this is called recovery actions, and it goes beyond just assigning the machine, because assigning machine is done automatically by injection 3. We're talking about what management tends to know very well is expediting, you know, splitting batches, going a subcontractor, doing that, all kind of things. Okay, but bear in mind that, you know, we set up the red zone to be able to, in rare situations, to sort out and finish the customer order within the red zone. What is important and what is unique about injection 4 is is that in TOC buffer management we shift the orientation of the time, because basically we're saying, here we are not in a good shape, we are in the red zone, okay? Traditionally, people will say, we are late, and will come with a lot of excuses and coverage and try to prove that it is not their fault that we are in trouble. in buffer management, the TOC way, we go forward and said, okay guys, what can be done? You guys have a lot of experience of how to expedite, okay? Use them now, before the panicking. We are not late yet. We just enter into the red zone, assess the situation, and suggest what to do. Injection 5, and this is the last injections that we will deal with today, is availability of selected critical raw materials and components is monitored and managed. We said that this wording is in the cases that we know that some raw materials tend to be troublemaker and they can have an impact in and block the ability to deliver on time. The reason for monitored / manage is depends on to what extent material management is a part of the implementation. If it's just production, production is monitoring and raising the flag. If it is a material management, then we expect them to actually manage actively this availability of raw material. So what we know is that for production we need materials and components from the outside. We call them the bought out. And there are two cases. One, bought out items are purchased to order, which is called PTO, and bought out components that are held in stock, and they are purchased through PTA, purchased to availability. So we look on the due date, we go back, production buffer, we want to release the work order, we go to the raw material store, we expect to find there material. The material, it takes some time to arrive through the procurement time. So in case one, yes, we just we release a purchase to order, we release a procurement order with a procurement buffer, and we manage it accordingly. In case two, we have a stock buffer, and whatever is consumed from the raw material store is replenished through the procurement process in a closed loop PTA. Next week when we deal with MTA, we will go into more detail into managing stock, both of the finished goods stock and material stocks, etc. So we are coming to the summary. I have been discussing the design of the solution. We said we have the low performance UDIs, current reality leading to the core problem, core cloud. Then we create the criteria for the good solution, that it improves the performance of the function, has good impact on the service to other function, and it contributes to the overall performance of the company. We go through the TOC pivot into the direction of the solution. Then the set of the injections. So far we have covered 5 out of the 8 injections of the MTO. They are leading to desired effect. They have been thoroughly checked for years and years for trimming the negative branch, the known negative branch, and the standard ones. And all of this create sort of the whole package that is associated with the solution. And of course, this is driven by the UDIs that were our guidelines for the solution. All of that leading to the high performance. Is for your reminder of the immediate improvements, injection 2, 3, 4, and 5, and we said this should be now more vivid and should be more easy to remember and to retrieve and get into them. So this is it. We've come to the end of this webinar for today. The time is as planned, so we reached the delivery to the finish line within time, within expectation, I hope, definitely. Whatever I want to deliver, I have delivered. I want to thank you very much. My email address is there if anyone has questions. Please feel free to send them by email, and I will respond eventually, hopefully in a short period of time. And thank you very much.
And
Bye-bye.
we do have actually about 4 minutes left. If anyone has a quick question they'd like to type into the question box, we can certainly look at that. I'd like to remind everyone that's with us today that registration for the 2014 TOC ICO International Conference is open, and we encourage you to take advantage of the early bird discount. Conference site rooms are selling out quickly, so don't delay. Complete your registration as soon as possible. Come to the conference to upgrade your TOC knowledge during 2 days of workshops and trainings taught by TOC experts from around the world, and choose from over 75 additional TOC presentations focused on a wide variety of TOC implementation success stories. This year's conference will also have a dual focus on the significant impact that management the TOC way is having on the government and public sector, as well as the healthcare industry. And also a reminder that membership in the TOC does have its benefits, with access to over 400 videos, over 50 webinars, discounts on TOC ICO products, as well as conference attendance. And please check our website. There's some wonderful, wonderful deals there. Next Thursday, we will have part 3 of Understanding Systems and Conflicts Through Clouds, Challenges of Cloud Consolidation Process with Yelena Perduco. And then on Friday, our third in this series, Managing Systems Part 3, Managing Stocks, Application of the Solution for MTA and MTIA, and that's by Odette Cohen. So let me look, do we have any questions? Doesn't look like it. Do you plan to make, yes, the slides will be made available soon. Takes us a little bit of turnaround time to get them up on the site, but Jessica will have those out quite soon. Anything else? Okay, Odette, very well done. Well within time, good job. You thought we might go over, but very well done, and looking forward to seeing you next week. And everybody have a wonderful weekend, and we do know the Broncos have a really good chance of winning the Super Bowl here in the U.S., which we're all crazy about, even though Jessica lives in Seattle where the Seahawks are. So
and that's
Jessica's
they're going to win
Seahawks against my Broncos, so we'll see what happens. All right, thanks everyone.
Okay.
Bye-bye.
Thank you. Bye-bye.